So before getting into the REST APIs, we would like to discuss a couple of things or a couple of more jargons like how to train a model and how to learn more about machine learning and artificial intelligence in general, the core neural network architectures and things like that. So that's what we're gonna touch upon in this particular lesson. Before we start, I would like to tell you something which we have seen in the previous session. So we have seen the session of LLM in which we were asking question about a Malayalam movie. And the answer I have checked after recording the session, I have checked. And it turns out that it is a complete lie. So LLM is trying to hallucinate in a very smart way. Personally speaking, I'm a person who has reasonable amount of knowledge in Malayalam movies. I'm a native of this particular language, my mother tongue. Still, I couldn't figure out whether this particular movie was there or not, because this is a Malayalam movie name. It sounds like a Malayalam movie name. And all the actors, all the story it is trying to mimic looks very reasonable and believable. It's saying that Adur Gopalakrishnan got Cannes Film Festival Award, all that kind of believable lie. So this is called hallucination in AI. Almost all neural networks has hallucination. To understand how hallucination happens, we need to understand how neural network works and how it is getting trained. We are not going into the details, but you need to understand one more technical term called hallucination. AI inference getting wrong, and sometimes can be pretty dangerous as well. For example, this time it literally got away with my knowledge in my Malayalam movie. I thought it was true. I had to check what all the movies Mammootty, the actor, has acted, and then I need to verify all the claims from the AI because it was looking very true. So we have discussed about hallucination and we have seen a live example. In fact, I was not planning to discuss, but it came up and I thought of explaining it. So AI hallucinates. Now, training. So probably training is the most complicated paradigm in artificial intelligence or machine learning, training an AI or a neural network. So training is all about generating that 14 GB file, 15 GB file we have seen, that model we have downloaded from the Hugging Face. So someone has trained that model to create that training data as well as training process. Two things are involved: the data which is needed for training plus the compute, the process. So compute is very intensive and expensive. We need very heavy and powerful, heavy in terms of compute, not in terms of weight, and powerful GPUs like H100, A100. These cards are very expensive cards, like 40k AUD for one single card. This is more expensive than that. You can check that. Probably there are more cards by the time you watch this particular video. So compute is one thing. That is more difficult to obtain is data. So we need data to train the AI. So someone has provided that information. All those information we have obtained from the AI. So someone has told the AI to give X inference when Y input is given. So input and output. So X1, X2, X3, X4, X4, and corresponding output Y1, Y2, Y3, and Y4. So this is the kind of format of the data we are giving to the AI. Pretty much almost all kind of neural networks. So we'll tell AI when we give X input, the expected output is Y1. For X2, Y2. In fact, that's how we humans learn as well. For example, when we learn mathematics, we look at some samples, working samples, which is evaluated by someone. We know the solution already before we start solving problems on our own. We'll look at problems solved by someone else. In that case, for example, in a math sum or a problem, X1 is a problem and Y1 is a solution. Like that, we will solve n number of problems before we get comfortable with that subject. For example, calculus, trigonometry, or any other physics or mathematics or chemistry problems. Science is just one example. Journalism, media, everywhere we practice. We call that practice. We already know the solution and we are trying that non-solution. We are understanding that non-solution. So there is a lot of process involved in this. One is something called a cost function. Not sure I have discussed it before. Cost function, you can read about it. Cost function or loss function. So this is all about minimizing a particular loss function or cost function. Cost to reach y1. Cost to reach y2 from x2. Cost to reach y3 from x3 through the paths of neural network. It's not a shortest path algorithm or anything straightforward. It's all statistical. So mainly to optimize this, two algorithms are used in tandem. One is gradient descent plus back propagation. So those are the two algorithms. Basically, we use back propagation to achieve gradient descent. That's how we do it to optimize the cost function. Backpropagation uses something very simple in calculus called chain rule. And this is working behind almost all the AIs these days, backpropagation and gradient descent. This is an algorithm or mathematical technique invented by Leibniz some 300 years back or 400 years, the time of Isaac Newton. You can read all about this in Wiki, very interesting topic, not complicated as you think. Chain rule, backpropagation, gradient descent, cost function, and another thing called activation function. So activation function is again trying to decide whether a particular neuron is activated or not. There are a couple of different types of these functions are there, sigmoid, ReLU, etc. So what I'm going to do is I'm going to give you links, videos, very interesting videos to watch and learn more about it. I'm planning a training on this topic my own. Till then, there are very interesting videos out there in YouTube and other sources if you're interested to get into such kind of detail. So what we've been talking about is the jargon training a model, hallucination of a model, training a model. So when people talk about all these things, you should know what it really means. Training is all about giving AI a particular input and getting a particular output. So it involves all about reducing this cost function for multiple samples. So we'll be running multiple samples. More number of samples, better it is. So we need data. Data is all about obtaining this x1 and y1 values. So that is data. So normally this is called labeled data. So labeled data or data with a label is you already know the expected inference. So you are telling AI, this is what you want. Use all the algorithms, backpropagation, and reduce the cost function to obtain y1 from x1. Now, this whole thing is all about matrix multiplication, like I mentioned before. Compute, that's where the GPU comes in. That's the reason why NVIDIA is the biggest company or the second biggest company in the world right now, GPU. So GPU is the compute requirement to do all this training. Training is very, very compute intensive. So all these algorithms ultimately does matrix multiplication one way or the other, and some other operations, obviously. So that is training. Next thing I would like to get our heads around is neural network architecture. So neural network architecture. So this is very similar to our daily life or the way we organize things in our world. So there is a neural network with a lot of neurons inside it. This is trained for a particular purpose. So for example, identifying the digits from an image, or anything like that. Now the output of this neural network can be given to another neural network which does something else with that number. Say adding two numbers. We don't need neural network for adding two numbers, but just an example. So this is another neural network. So neurons are here. So this is the image coming in. So there are two images being picked up. So this is the image of 2 and this is the image of 3, and two neural networks are here. Convert it into number 2 and number 3. So this is the image, this is a number. A lot of difference. It looks similar, but different stuff. This is the image, output is number 2. Now what this neural network does is it add and output number 5. Or it can take the image of an operation, for example, the image of an operation, say plus, and whatever is that operation, it converts and output 5. So the architecture is combining different neural networks and achieving certain goal out of it. There is more details to it rather than the simple example I have given, but the idea is very similar. One example in real world is transformer. For example, it has an attention block, it has encoder, decoder. There are a lot of different types of transformers are there, mixture of experts, all those different neural networks, which does specific thing. Input of one is given to the output of other. So if you hear the term neural network architecture, this is kind of not exactly what I explained, but kind of what it is. Example is transformers, mixture of experts, and things like that. You can read more about it. So what I'm going to show you is some of the very good resources to learn more about this topic, because we won't be discussing this topic in this training after this, because our objective is understanding the cloud AI offerings. That's our original objective. So these are some of my favorite videos when it comes to neural networks. So good starting point is 3 Blue Brown. So it is a series from 3 Blue Brown. There are a couple of videos. So it is explaining gradient descent, transformers, a lot of details. Once you start watching this, I'm pretty sure YouTube will recommend almost all the details and all the things which you need, and further watch things. But this is a very good start, this particular video, deep learning neural network. Some of the animations in 3 Blue Brown is a little distracting, so pause the video and think while you watch the video, because some of the animations I find it a little distracting than helping, but that's what people like. I'm sure that's why he shows these animations in repetition and things like that. But a very good start, go for it. The preference I have is something different. Once you are familiar with the basics, the preference I have is Andrew Karpathy. This is the channel. This is more my kind of learning. I would go with his videos more than anything else, but a little bit of background is good to follow his videos. Again, he has a lot of series and long videos for our video, but it's really worth it. If you want to really get into the field of AI, this is what I recommend, his channel and his videos. Very basic. He has a GitHub code base. I hope I'm typing his spelling right. Andrew Karpathy. It's, I think, pronounced as Andrew. So a lot of code in this particular place. So micrograd is very good start. Micrograd. Then make more. Make more is really good. A lot of different neural network architecture. You don't have to know PyTorch for this, although it is using PyTorch. But if you want to get into the details of PyTorch, it's not that hard anyway. So that is the 2 resources I would like to recommend. Start with 3 Blue Brown and go to this if you want to learn more about it. So we have seen the gist of training a model, and also we have seen things like hallucination, where things can get wrong. This is one of the major things with all the AI models. Just like humans, they can get wrong. This is the main difference between a normal program and an AI or a neural network based program. They can get different results. They can hallucinate. And also we have discussed some very good resources to learn more about it. Algorithms like gradient descent, backpropagation, all these algorithms, attention mechanism, all this can be learned from some of the resources we have shared. I have my own course coming up, but till then you can use these links.